Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel at Weber State University in Ogden, Utah. In this series of videos, we are going to look at the 2017 and above Toyota Prius Prime, as it's known here in the United States, the Prius plug-in as it's known outside of the United States. The Prius Prime has a unique 351.5 volt lithium-ion battery that's rated at 8.79 kilowatt hours. And I have one here that I've totally disassembled. We are going to take a look at the pieces of it, get some specifications of it, take a look at some scan tool data for it, and reassemble this battery and show you how it fits inside the vehicle. We will look at the plug-in charging system and how that works. We will look at the electric vehicle mode versus the hybrid vehicle mode, and a few other unique things about this vehicle. So let's get started. Okay, as you can see behind me here, I have a 2017 Toyota Prius Prime. The battery I'm using in this demonstration is from a salvage yard. I have totally disassembled it. What I have here behind me is the empty shell of the battery. All of the pieces of the battery are over here on the table, and we'll take a look at those and put the whole thing back together. But there's a special procedure to remove the battery from the hatch area of the Prius Prime. Now, the regular Prius, the 2016 and above Prius, the high voltage battery is under the back seat rather than behind the back seat. But this one is not only behind the back seat, but it fills up the entire hatch lower area and then comes up a little bit higher. Okay, before you remove any high voltage battery from any vehicle, you must disable the high voltage system. That typically involves turning off the vehicle, removing the key or the key fob, disconnecting the 12-volt battery, putting on your personal protective equipment, your high voltage gloves, removing the service disconnect lever or the service plug grip as Toyota calls it, and then using a verified good multimeter, voltmeter, to verify that there is no high voltage on any of the high voltage wires, the orange colored wires and cables that connect at the battery, and then disconnect all of those. Disconnect any other brackets or bolts or hoses or whatever there may be. The battery on this Prius Prime here is air cooled, so there is no liquid cooling that we have to drain. This has air that is pulled from the passenger compartment and blown through it. So what I have here is an engine crane connected to an official Toyota service tool, these yellow straps there, that connect to 4 different lift points on the battery. And then we use an engine crane, as you can see, that I have hooked up here to remove the battery. But it's a tight fit. So let's get in here closer and take a look at getting this battery out. Now, once again, this is not the battery, the real battery in the vehicle. It's still in the vehicle. This is just my salvage yard battery sitting on top of the real battery in the vehicle. All right, well, let's lift this up and get this out of the back of the Prius Prime. We got to make sure we've got clearance. We're not hitting the deck lid, the hatch lid, or the back glass. Let it down just a tiny bit. And I've got some fender covers installed to avoid scratching any paint or plastic parts the best we can. Just going to let this roll back. All right, as you can see here, this is the battery housing for the Toyota Prius Prime. It's pretty big compared to the regular batteries that we've seen in the just regular Priuses, the non-plug-in varieties. On the front of the battery, there are 3 covers that cover up the electrical connections, the high voltage connections, and the low voltage connections. In the back of the battery, we have the air inlets. These 1, 2, 3, 4, 5 hybrid battery intake ducts are where 2 cooling fans in the back of the Prius will pull air from the sides of the rear seat and pump them into the battery, and then that air comes out right here in the middle in the back and goes out the little vents in the side of the inner fenders right here. But it also, you'll notice the battery housing itself is not sealed, totally sealed. And so air blows out the sides and it all blows out underneath, and you can see a kind of a foam element right here, the cover that goes on top of this battery, and that forces that air to go out the side one-way vents in each rear fender. So the conditioned air, whether it's heated or cooled, gets pulled in and pumped into the battery and then pushed out outside the vehicle. Now, any battery that's inside the passenger compartment or trunk area, by law, has to have a vent in case the batteries start gassing. And so this little piece right here, the official name is the #1 hybrid battery exhaust duct. This is the vent in case the battery gasses, which it never should under normal conditions. But if it did, there's a vent tube that goes down through the floor in the back of the vehicle here, and we'll take a look at that here in just a moment. There's a cover right here on the top where we would access the service plug grip, and we'll take a look at that here also. But I just wanted to show you the empty housing. I put some casters on the bottom of it once again so I can roll it around in the shop without having to get my engine crane out to move this. But let's get this set off to the side here, and we'll take a look at a few of these pieces inside of the vehicle itself now. Okay, before I show you the high voltage battery electrical connections and the plug-in charger controller and everything else inside the back hatch here, let's talk about the plug-in charging receptacle. So on the right rear of the Prius Prime here is the charge receptacle. And here in the United States, we have the standard Society of Automotive Engineers standard J1772. Now, according to Toyota documentation, this connector receptacle here, charge receptacle, meets the J1772-2008 standards, and those have been revised over the years and will always be revised. Right next to it over here is a place where if you are outside of the United States, you will have a different charge receptacle, most likely. From the shape of this looks like the GBT charge receptacle connector that, for example, China and some other countries are using. If you look at this photograph here of a connector that a friend sent me that's used on a Tesla vehicle, you'll see it has the same outline here as this one. And interestingly enough, on the Toyota TechStream scan tool, it actually shows some DC Quick Charge options, which that GBT charge receptacle gives on some vehicles. So I don't know for sure if a Chinese version of the Toyota Prius Prime or Prius plug-in would have DC fast charge or quick charge, or if there are European models that have that option. If you know, put it in the comments box down below and let all of us know, because I can't find anything yet indicating one way or the other. Now, when you plug in the J1772 charge connector here to whatever voltage, the 120 volt, the 208, or the 240 volt, we only have 208 here at our school. It can take 4 or 5 hours to charge this battery. So yesterday I ran this battery all the way down to where it went into hybrid mode and had the internal combustion engine turn on. And at that point, I shut the vehicle off and plugged in the charger here, and it took almost 5 hours at 208 volts AC to charge this DC 351.5 volt battery. So there has to be some device that takes the AC power that we plug into the side of the vehicle and change it to DC and change the voltage to match the charging of the charge level of the battery itself in the back of the car here. So let's take a look at that next. Okay, as you can see right behind me here, we have removed the rear seat, the lower cushion, the center console, the upper cushion, and on the floor under the right rear seat cushion and the center console is the plug-in battery charger assembly. As you can see, there are two orange electrical connectors at the plug-in charger. The one on the right is a 2-pin AC voltage connection from the plug-in charge receptacle on the side of the vehicle. The one on the left is the DC high voltage output that goes and connects at the high voltage battery in the hatch area. So AC in on the right, DC out on the left. Okay, here in the hatch area, this connector right here is the back of the J1772 compliant charge connector. So you can see the orange cable with the two wires that runs up and to the battery charger assembly where it converts the AC into DC to charge the high voltage battery. But also, while we are here, there is a green wire right here. That is the ground circuit, the earth ground circuit on our plug-in charger. So it's a 3 cable. So it's a 3-terminal plug-in as far as the AC voltage is concerned. We have the hot and the neutral and the ground. The ground of it connects right to the chassis of the vehicle right here. And then the hot and the neutral are the two wires that go down to the charger assembly under the back seat that we just took a look at. Under the charge receptacle, while we're here, there's a drain tube. This tube right here, if we zoom out just a little bit, you can see that drain tube goes all the way down and through the floor. So if any moisture gets into that charge connector, it does have a drain to get down and out of there. There are two small wires on the J1772 charge connector, and you can see those two wires right back here that connect to the low voltage system on the vehicle. While we are back here, our service plug is accessed right here. We've removed this cover to access the service plug, and as I said before, we will remove that anytime we want to disable the high voltage system, but only after we've done some preliminary steps. There are also, as you can see here, other electrical connectors that connect at the front of the battery. So while we are here in the back of the vehicle, let's take a look at the battery vent system in case it gases. As you can see with the label here, we have vent gases that would come down and go out the floor through this tube. This little tube right there that you can see just goes through the floor. And then on the left and the right sides of the battery, we have these ducts where there are blower motors, 2 blower motors. So we have one blower motor right there that pulls air in from the side of the rear seats and then pumps it into the back of the battery here. There are 2 pieces of ducting that allow this blower motor here to pull air in from by the seats there. And so we have this piece right here that's going to come in and connect to the front of that blower motor right there. And then this piece of ducting connects to that and goes down to the side, the right rear side of the rear seat. And this big opening right here connects to a filter, just like this. and you can see the inlet on the right rear side of the seat cushion, which would be right here. So this inlet, and there's one on the left side also, so there's two inlet ducts on this high voltage Prius Prime Prius plug-in battery. These you want to make sure are vacuumed out periodically. Pet hair, dust, lint, whatever it may be, don't block these with coats, pillows, or whatever, because the battery, when it starts to get hot, can overheat. And then you'll hear these blower motors running, and we'll run these a little bit later so you can hear how they sound, but you can definitely hear them when they're turned up to their maximum speed, when and if the battery gets really hot. So there are ducting on each side. There's a blower motor on the right, blower motor on the left, identical ducting on both sides, two inlet vents to pull in either cool air in the summertime when you've got the air conditioning running, or warm air in the wintertime when you've got the heater running. If you think you're going to save energy and be more efficient by not using the air conditioning, that may be actually detrimental to the life of the battery on hot days. So they need to be kept cool. So running your air conditioning is actually how these are kept cool. The air cooling is a really good design. I believe the liquid cooling is even better, but this is a good air-cooled battery. And Toyota's used air-cooled batteries in almost everything they have for many, many years. All right, well, let's take a look at the wiring at the front of the battery now. Okay, we're here in the back seat area of the Prius Prime, and let's find a point we're familiar with. The J1772 charge connector, the back side of it right there. We have our hot and our neutral cables, the two wires that come in, and if we follow them, they come in and go down and go to the electrical connector on the left of the screen that we can't really see. The connector on the right, that one there with the little green mark on it, is our DC output from the charger, and if we follow that cable, comes up, and these two small wires right there comes over and up, and the one on the left of our screen, that one right there, that smaller wire and the smaller plug-in connector, that is the negative terminal of the battery for the charger. And then on the right hand side, that little wire right there is the positive side, so DC input to the battery. Now those two great big electrical connectors that are right there, the two big cables, those are the two cables that go all the way up front to the inverter with converter assembly, and that cable comes in and goes over and down through the floor right there, and then under the vehicle up to the inverter with converter assembly. All right, so we've got our charger in the back, we've got the two connections from the charger DC to the battery to charge it, and then we have the two large connectors at the battery where they connect to the inverter converter to drive the vehicle and to receive regenerative braking power. Now we also have some other electrical connectors on the front of the battery. Right down here, these white electrical connectors, those two connectors right there are our low voltage connections, where we have a lot of serial data, powers, grounds, constant battery power from the 12-volt system, because remember the 12-volt system is used to control the high voltage system. So we have low voltage connections, we have high voltage connections. All those other orange cables you see there are internal connections between the battery stacks. So we've removed all the covers on the front of the battery so you can see what's going on there. But normally you would never need to take those off unless you were servicing the battery or changing the battery. Okay, before we dive into the internal parts of the high voltage battery, I want to talk about the charger assembly just a little bit more, the plug-in charger assembly. So I've got one of these used from a wrecked vehicle as well as the high voltage battery, but I just wanted to show you a little closer better view of the charger assembly with our AC voltage connection here and our DC output there. So AC in, DC out. This little black cable right here in between the AC and DC is 12 volt output. And it's actually, I shouldn't say 12 volt, it's a 14 volt output. So this has what's called a sub DC to DC converter in it. So on all of these hybrids I have behind me here, the first, second, third, and fourth generation Priuses, in the inverter with converter assembly, the converter is a DC to DC converter that uses the high voltage battery power to charge the 12 volt system on the vehicle, and it steps it down through transformer action in the DC to DC converter that's typically underneath the inverter assembly, and it is serviceable on the second, third, and fourth generation vehicles. And I'm going to have a video on how do you test that a little bit later. But this has an additional DC to DC converter in it, the plug-in charger. And what that means is when you plug in your wall charger to your plug-in Prius or your Prius Prime, it's going to keep the 12 volt battery charged while the charging is going on of the high voltage battery. And it needs to do that because if the battery gets hot and it needs to run those cooling fans, we don't want our 12 volt battery going dead running those cooling fans, because the entire vehicle runs on that 12 volt system, other than the transaxle, the inverter, the air conditioning compressor, and of course the high voltage battery back here. And there may be a few other systems, depending on what car we're talking about, that run on high voltage, but the rest of the vehicle is low voltage. And so if the battery gets hot, then we need to cool it, and we can run those those low voltage fans to keep it cool. There's also an option to run the air conditioning compressor, and you can turn that option on and off in the settings on the instrument panel, but by default it's on, I believe. But you would probably want to leave that on, because it will allow the air conditioning compressor to turn on and produce remove heat from the air, so that we would have cool air to pull into this air-cooled battery if it were overheating. Let's say you're trying to charge the battery and it's a really hot day anyway. The battery needs to stay within a certain temperature, and it'll run those cooling fans to try to keep it there. But sometimes it would be beneficial to have refrigerated air there to help cool it as well. Now, this charger assembly here is also an air-cooled piece, and it has an inlet duct right here and an outlet. The inlet, it pulls through a little vent in front of the lower rear seat cushions, and then it has this little DC brushless motor right here that pulls in air and blows it across these little heat sink fins and blows it back out inside the passenger compartment. So that produces heat as well as you're trying to charge the battery. And on a cold day, that's no big deal, because that heat is used to help warm the battery. But on a hot day, the heat produced from the charger assembly can aggravate the temperature of the high voltage batteries it's trying to charge. There's also a battery heater, but on cold days, when the temperature drops below 2 degrees Celsius, which is like 36 degrees Fahrenheit, the battery heater will come on. And it's a low voltage heater, which once again is why the 12 volt system is kept charged at almost 14 volts while the high voltage system is being charged. And it shuts off around 43 degrees Fahrenheit, which is 5 degrees approximately Celsius. So that is the plug-in charger assembly. We take AC voltage, convert it to DC, high voltage DC to charge the high voltage battery, low voltage DC to charge the low voltage battery, all at the same time. Once the high voltage battery is charged, then we also quit charging the 12 volt battery on the system. Okay, now that we've looked at the major components inside the vehicle related to the high voltage battery and its charging, let's take a look at the battery itself. Now remember, this is an empty battery housing. I have all the internal pieces on the table behind us here, and we will take a look at each of those in great detail and put it together. But while we're here, let's take a look at a few things. There are 4 lift points for this strap, and they are specifically marked with little arrows in the aluminum. There's an arrow right there by 4 of the lift point holes on this battery. So there's an arrow right here, there's an arrow right here. Then on the back side corners of the battery, there's a hole with an arrow indicating that those are the 4 lift points for this strap assembly, which is an official Toyota special tool. But it's just a strap from the Stren Flex company, rated at 2,400 pounds. So the battery doesn't weigh even 300 pounds. So any good solid strap with some good hooks that aren't going to come loose while you're removing the battery should work just fine. All right, there are several labels on this battery. Let's take a look at those next. Okay, so this first label gives us the part number of the battery assembly and tells us that it is rated at 8.79 kilowatt hours. The label right below that is our high voltage warning label, warning us that there's high voltage inside. It gives us a symbol with a hand crossed out, which means don't touch without personal protective equipment, or PPE. Then we have a high voltage shock symbol and a caution symbol. Okay, the next label that we have here has several pieces of information on it. It tells us this was distributed by Toyota of Canada, which is it's interesting. I never noticed that before. The salvage yard I bought it from was in Canada. And we have lots of warning symbols and icons. These are universal ISO symbols and warnings telling us this is a lithium-ion battery, and it tells us to always observe the following precautions when handling this unit, and gives us a list of things to do. Gives the information to qualified technicians, telling them to refer to the service manual. Gives us transportation and dismantler information, telling them to refer to the dismantling manual. Contact a retailer or national distributor for take-back, recycling, transport, and or removal of this unit. And there are special requirements just for shipping the battery, and then recycling information as well here on this label. Okay, on the front of this battery there are 3 covers. This cover here on the passenger side is the cover that technicians would have to remove to get in and disconnect those high voltage cables from the charger and the ones that go all the way up to the inverter assembly up underneath the hood. Over here on the driver's side is a small cover that has to be removed to get to the low voltage electrical connectors that we looked at behind the back seat there, the ones where we have communication and power and grounds and whatever else there is necessary for controlling and communicating with the battery itself. And then this last cover right here, this shield panel, is removed when you do internal service work on the battery itself. So let me get these covers out of the way. We also have the service disconnect lever, or service plug grip as Toyota calls it, cover that's here on the top of the battery. Just has 4 bolts that hold it in place, 4 nuts that hold it down, and we'll get that out of the way. And then finally, there are 20 nuts and bolts around the outside of the upper cover of this battery that I've already removed, and we'll just lift this cover up and off next. So here's the bottom of the cover and the top, and it's pretty rigid. It's fairly heavy. Let me get it out of the way now. Okay, so what we see now are 5 slots for 5 stacks of lithium-ion battery cells. There are 5 stacks of 19 cells each, giving us 95 cells in series with each other at 3.7 volts each for a nominal voltage of 351.5 volts on this battery. Now yesterday when I charged this battery, the initial charging voltage was 331 volts, and the maximum voltage that it charged to was 373 volts. So at 331 volts divided by 95 cells, that gives us a cell voltage of 3.484 volts when the hybrid internal combustion engine comes on to provide power to recharge the battery. And it only charges it at 336 volts. And it increases about a 1.5 to 2% state of charge before the engine shuts off, and it sits there and will cycle on and off for hours and hours and hours without charging the battery any higher than about 336 volts. Now at 373 volts, where the charger shut off, if we divide that by 95 cells, that gives us a maximum charge voltage of 3.92 volts per cell. At least yesterday in the shop at pretty warm temperatures. It was probably 80, 85 degrees Fahrenheit here in the shop. Okay, so we've got 5 stacks of battery cells that go in here. They all have temperature sensors. There are 2 big hybrid battery junction blocks that have contactors and resistors and current sensors and temperature sensors. And then we have the battery ECU, or the BMS, the battery monitoring system, which monitors the individual cell voltages. And yes, you can monitor all 95 cells for their cell voltage and their internal resistance on the scan tool. And then we have internal ducting for cooling that we need to look at, and internal ducting for venting if the batteries were to overcharge and overheat and need to vent gas. So all of that is coming up in our next episode. Thank you for watching.